All right, we're back. We got Evan. Bringing him in now. There he is. Hello, sir.
Hello.
All
Hello,
right.
everyone.
Great to have you here.
Yeah, glad to be here. Can everyone hear me? Okay.
Yep, we can hear you. So I'm going to just do a quick little intro here, Evan, and then you can take it away.
Sure.
So I just want to do a quick thanks to Algolia for sponsoring Evan's talk and Laracon Online. Definitely check them out. They power Laravel.com's doc search. If you need a search engine for a project or an app, definitely check them out. Fantastic service. And again, thank them on Twitter if you could for being a sponsor of Laracon Online. All right, so Evan Yu, creator of Vue.js, is going to give us an inside look here at Vue Templates. So take it away, Evan.
All right. So hello, everyone. I'm Evan, and I'm actually dialing in from Shanghai, China. So it's pretty late night here, so I apologize if I cannot speak very loudly because people are sleeping, but I'll try my best. So today's talk is about inside Vue templates. I'm pretty sure a lot of you have used Vue and have wondered what happens under the hood when you pass a template to Vue, and why does it just become reactive and updates when you change your stuff in JavaScript. So so this talk is just going to be sort of like an overview of what exactly is going on. We probably won't be able to fully explain every little detail of it, but I hope you can get a better understanding of what Vue is doing when you give it a template. So let's get started. So you've probably all done this when you first started trying to use Vue. We have this very, very simple template that has an interpolation tag inside of it, and you give it some JavaScript, sprinkle some Vue stuff over it, and boom. So yeah, it's kind of like magic for the first time you try it, but it really is not. It's all like code underneath, right? So how does it work? So now we're going to get into something that's more technical, right? So for the initial render, what Vue does is we'll take your template and compile it into something called a render function. So bear with me now if you have no idea what a render function is. So just so you know that the render function, when called, it returns something called a virtual DOM. And now, hold on, before you ask me what the hell is a virtual DOM. So the virtual DOM, when we finally get the virtual DOM, Vue will then actually generate the actual DOM. So this is what happens at a very, very high level. So now we're going to dive into it and try to explain a bit more about what each of these actually means. So before that, on subsequent updates, so how does Vue know like what to change, right? So because we had the render function that we got from step one, whenever something changes in a component, some data changes in the component, we'll call the render function again. And this same render function, when it's called, because it relies on the data and the data has changed, so it'll return a whole new virtual DOM structure. So now we have two copies of virtual DOMs. We have an old one and a new one. We will just diff the new one against the old one, and magically we'll somehow figure out what has changed between the two, and we'll apply these changes to the actual DOM. So we don't actually conceptually, the difference is that we are generating a whole new virtual DOM, but we are only applying the minimal actual updates to the actual DOM. The whole reason for doing this is mostly because virtual DOM is fast and actual DOM is slow, and we'll get into that a little bit later. But this is so this is the very high level idea of what happens on initial render and on subsequent updates. Okay, so what is virtual DOM anyway? It might sound very fancy. It's a very fancy term, right? I think it was first introduced by frameworks like React, and it quickly got adopted by a lot of. There are a lot of competing implementations and people trying to explain what it is, but still, it kind of feels mysterious if you've never actually looked at the internal implementation of a framework that uses virtual DOM. So I'll try to explain it in very, very plain terms. So the comparison here is actual DOM. You create an actual div element with the native browser API, for example, document.createElement, right? So this returns a real div that you can append to the document, and it'll actually appear on the page. But a virtual DOM element in Vue's context, we created with a method, an instance called create element. So I imagine very few of you have probably actually used this because this is a relatively advanced or low-level API that you would use to manually write render functions. But what it actually returns is just a plain JavaScript object. So to put it another way, if you call toString on the real div that we created earlier, you'll see some string like this, object HTML div element. Right? And if you're familiar with JavaScript, you probably have seen a similar string many times when you call toString on some native objects. For example, if you call toString on some native browser object like the document, or call it on the native like promise constructor or something like that, you will get this really weird string with like a square bracket object something. So this usually means this thing is native. It's not implemented by you in JavaScript. It's actually implemented by the browser, and it just exposes a JavaScript API that you can use and leverage. And the virtual DOM object, in comparison, returned by Vue's $create_element method, is just a plain JavaScript object. So if you inspect it, you will see that it has a tag attribute, which is this div, and has a data object, which contains what attributes it has, and some other additional thing that Vue would rely on internally. And then it would have a children property, which is just an array of more virtual nodes inside of it. So this is basically a virtual node. A virtual node can obviously contain more virtual node children, and when they form a tree, they become a virtual DOM tree. That feels kind of similar to the actual DOM tree, but is much more lighter weight. So it's kind of hard to so I'm not a super like experienced with the internal like C++ level implementation of browsers, but generally browser native DOM objects are expensive to create. They're expensive to even access because whenever you try to access a native object in the browser, you are essentially crossing the boundary from pure JavaScript land into bridging into the native C++ land, and that has a cost. And even just accessing the DOM, the native DOM, has a cost. And mutating it or creating these DOM elements are much more expensive than creating and mutating simple JavaScript, plain JavaScript objects, because you just stay in pure JavaScript land and you never have to cross the bridge. So this being cheap allows us to call this render function repeatedly without worrying too much about performance. Because imagine a naive way of doing a DOM update is whenever something changes, we just throw away all our previous actual DOM and recreate everything from scratch. That gives us a very straightforward mental model of how to do things. It's sort of like just render a new template every time things change. It's really straightforward to do so, but the performance of real DOM objects doesn't allow us to. It's just too slow. but the virtual DOM allows us to do that. So it gives us a relatively straightforward mental model for how to describe what we want at a given point of time, but still gives us really acceptable performance to do that. So yeah, so to sum up, virtual DOM is essentially a lightweight JavaScript data format to represent what the actual DOM should look like at a given point in time. The key here is at a given point in time, because whenever something changes, we will create a new copy of it. It's essentially immutable. And this characteristics means it needs to be very cheap to create. So we cannot actually do this with the actual DOM. We can only do this with the virtual DOM, right? So there's a common misconception that people think virtual DOM is what makes frameworks like React or Vue super fast, like thinking that virtual DOM allows us to create performance that's even better than vanilla JavaScript, like direct DOM manipulation. And that's actually false. That's actually wrong. Virtual DOM still has its own overhead. So a virtual DOM-based implementation is very unlikely to ever be faster than a hand-tuned vanilla JavaScript implementation. The reason we're okay with that type of overhead is because virtual DOM brings some extra benefits. And the benefit is that it allows us to decouple our application's rendering logic from the actual DOM. So because they're just plain JavaScript objects, right? And we need to realize that JavaScript not only runs in the browser. Today, it runs on the server side inside Node.js. It runs it run inside an embedded JavaScript engine in a native web app, the native mobile application. There are many different environments that are not browsers. They don't even have a DOM API, but they can run JavaScript. And having a virtual DOM basically means we can run our Vue application virtually inside any environment that supports JavaScript. And we can still generate this virtual DOM representation of what we should render. And when we try to output stuff to the user, instead of creating an actual browser DOM, we can just change the generation algorithm and target a different output format. So for example, server-side rendering is essentially taking the virtual DOM and stringifying it into plain HTML. Right? That's server-side rendering, demystified. Native mobile rendering is essentially changing all these calls to native DOM APIs. For example, create element and insert before. We're changing these calls to a wrapped API that's actually making calls to the native mobile rendering APIs underneath. For example, we're actually making a call to Objective-C code or Java code on Android. So this is what virtual DOM actually brings us, and this is a very powerful capability that allows frameworks like Vue and React to not only just work in the browser, but expand this whole paradigm into multi-platform usage. So server-side rendering examples, the Vue Hacker News demo uses server-side rendering and has very good performance scores thanks to that. So unfortunately, Vue server-side rendering at this moment still is tightly coupled to Node.js. So if you want to leverage it inside Laravel, you probably would have to spin up a separate node process and sort of proxy back and forth. I have got requests from users that want to try to run Vue server-side rendering inside the PHP v8 JS wrapper. But I don't think that's going to be ideal because the wrapper itself, the performance, I haven't really looked into it, but I don't think it's going to be better than a plain Node.js process. And the additional problem is without the node host environment, we lack some of the useful APIs that Node.js provides to provide a better rendering performance and experience. So it's something it's something we actually intend to look into, how to make view server-side rendering work nicely inside Laravel environment. But at this moment, we don't actually have a very good answer to it yet. Native rendering via Weeks project. This is a project started by engineers at Alibaba, which is the biggest e-commerce company in China. And they recently donated the project to Apache Foundation. So it's not that they are like throwing the project away, but they are essentially joining Apache to let Apache Foundation sort of formalize the process and to guide them in how to make this a better open source project. So and yeah, this is the same Hacker News app actually implemented using Weeks with almost identical Vue single file Vue component code. So and all of this thanks to the existence of Virtual DOM. Okay, so going all the way back to, so we've explained what the virtual DOM is, why it is important, why did Vue implement it, and now we can finally define what a render function is. A render function is basically a function that returns virtual DOM, right? The render function returns virtual DOM, and in Vue 2, you can actually manually write render functions, but I personally don't do that all the time. It's very powerful, obviously, but it only caters to some very advanced use cases. And most of the time in application level code, I still write templates because templates are easy to read. And how do we turn templates into render functions? So this is the job of the compiler. So many of you have probably had the confusion when you are upgrading to Vue 2. We have this difference between two different builds, the standalone build and the runtime only build, right? The difference between the two is whether it includes the compiler. And all the compiler does is compiling templates into render functions. So we'll explain what the compiler is first, and you will probably have a much better understanding of the difference between the two builds. So the compiler obviously is responsible for compiling the template into render functions. And if you're interested to see how it actually works, there is a little demo app called Vue Template Explorer.now.sh. You can paste. Let me just open this real quick. You can paste code Vue template to the left, and you'll see what is generated on the right. As you can see, this _C is really just a alias for the create element instance method. And you can see we're creating a div virtual node with some attributes, and the attributes is found here, ID app. And the third argument is an array, and the array represents the children to this virtual node. And these are a lot of like internal helper methods. The _v essentially means create text node. _s is just it's a function that normalizes arbitrary input value into a string. So I think this is you can probably read this and kind of figure out what it does, right? It creates a virtual node and returns it. And to get a better understanding of what it really does, we can try to play with it. And for example, we can wrap this inside a span. And now you see here we just wrapped it inside a span call, and the text nodes are now nested inside an array. And when you do something like v4, so v4 equals item and items. So what happens there? You can see we see this new helper method called _l. This is a helper for rendering a list, right? So it takes items, which is our source, the data source for the repeated list. It's probably an array. And this is kind of like array for each, right? We pass it a function. Says my internet connection is unstable. So I hope my voice is still okay. So I'll just assume it's fine, and I'll just go on.
It's good, Evan. You sound fine.
Okay, cool. So we have this this is basically an iterator function, right? So think of it as actually items.map. The JavaScript map function will take each item inside an array, and when you return something from the iterator, it'll just create a new array with mapped items. So inside the iterator, we'll just return a span element. So now this whole expression just returns an array of span virtual spans. And these virtual spans are then passed to this div as its children. And another example is the vif. Vif is just compiling to a ternary expression. So OK is our expression, and if OK is truthy, it's in JavaScript, truthy basically means it's a not zero, not empty string, not false, not undefined, not null. But whenever it's truthy, we will return this span. Otherwise, we'll return this thing. This thing is just an alias for creating empty vnode. This empty vnode will just render into an empty comment tag in your final DOM. And the reason that we are returning an empty node instead of just returning nothing here, it has to do with some internal optimizations, because when you have a long list items and some of them has a vif, toggling them would, if we return nothing, toggling them would change the whole length of the list, and that would make the diffing a little less efficient. If we keep the same length of two lists when we toggle the things, so the diffing algorithm becomes much more efficient because the list is more stable. But these are just internal details. So we kind of have an idea of how templates are actually compiling to these render functions now. Let's get back to our presentation, and we get back here. So what we have here, right? So this is directly from templates into render functions, but there are more details inside, right? So if you've ever written a compiler before, you probably know that a compiler usually involves some different phases of compilation. The first is usually tokenizing or lexing, essentially parsing your raw input strings into a data structure that you can then process and work with later on. So in Vue, this is relatively simple. We just directly parse the template into an AST, which is an abstract syntax tree that represents the structure of the template. And luckily, because Vue's templates are all valid HTML at the syntax level, we can leverage the existing HTML parsing logic to do a lot of, essentially we can leverage some of the existing implementations and parsing logic of JavaScript-based HTML parsers. So this is an example. For example, if we have this template string, the parsed AST will probably look something like this. So this actually looks very, very similar to a virtual DOM, but the difference is that it mostly contains the raw information of what the template looks like. So the biggest interesting part here is that this AST node that represents this interpolation has a type expression. These are just constants, and it has a value of string message. Okay, so note that this is not exactly the same with what Vue uses internally. This is greatly simplified for demonstration purposes, but I think you get the idea. So we first parse this template into some structure like this. Then we need to turn this AST, this abstract syntax tree, into code. We get input as a string of templates, and what we output is a string of JavaScript code. So we need to turn this intermediate format into code. And that's what the code gen does, the code generator, short for code generator. So when we take the AST as the inputs, we create something like this, return create element div, this just an empty object that represents an empty data for this div, because we didn't have any attributes in it. And then its children is just an array, and it only has one children, and it's create text message. So again, this is a simplified version of what we saw earlier in the template explorer. And you can largely see the similarity now. So this is the whole process of compiling, going from a template to a render function to the generated virtual DOM. And then Vue has this patching algorithm that compares two pieces of virtual DOM. Has this patching algorithm that on the initial render will take the virtual DOM and generate the actual DOM, and on subsequent updates compared to virtual DOM, apply necessary DOM updates. So putting everything together, this is a diagram that some of you might have seen before, but this is, we should probably like circle this whole thing up inside what a component does, right? Each component have all these corresponding parts. Every component has a corresponding watcher. Every component has its data object. Every component has its own render function. We're just ignoring the template compilation parts because it's strictly not necessary, because if you manually write a render function, we essentially just skip the compilation process. So on initial render, we'll generate the virtual DOM tree and generate the actual DOM. And during that process, this is how Vue tracks changes, right? Because inside our virtual DOM render function, if we go back to the Explorer, and if we go back to the most simple example of what this looks like, you'll see that this generated render function uses the with this block. So this is this is probably the topic of another talk, because using with greatly simplifies our compilation pipeline. But when you use something like Vue Loader with Webpack, we actually performs an extra compilation pass that strips the with, so that the final code is strict mode compliant. So when you strip with, you will see something like this. We can ignore these parts. They're just defining some variables, and you'll see that we now prefix these calls, and most importantly, we are using VM.message here, right? So this .message is an access, and we know that the VM instance inside Vue proxies the access of a data property to the actual data. And when the render function is called, VM.message is accessed. And when it is accessed, it triggers the getter that we have defined on the data. And that getter let us know that, okay, this render function depends on the message property in the data of this component. And this is what happens here. So during the render function will touch everything it needs. It'll touch everything that it depends on, because it will have to invoke all the getters of the properties it has used inside the render process. And that will, in turn, notify the watcher and let the watcher collect these properties as dependencies. So after the initial render call, the watcher would have collected an array of dependencies that have been relied upon during the render process. And now, whenever one of these dependencies change later, the watcher will know, okay, because the things you have depended on has changed, you probably should rerun. You should render again. And that's when the render function will run again and generate a new virtual DOM tree. And then Vue will patch, compare, and diff them, and then apply the updates to the DOM. So this completes the whole circle of updates. And I think this is at a very high level. This is what happens in every Vue component that you have ever created. We've explained what this works, and there are some extra topics I kind of want to touch upon, because there are some common questions that I get or confusions among developers that I've seen, and it very much has to do with the understanding of how all these work under the hood. So once we've explained all of these, it becomes much easier to explain some of the other questions. For example, the previous mentioned topic of the standalone build versus the runtime only build. So the runtime only build does not ship with the compiler at all, which means there's nothing in the runtime only build that can handle a plain template string, because it doesn't know how to compile it. The only thing it knows how to handle is already compiled render functions. So that is why when you use the runtime only build and you try to give it a template, it'll just give you this warning saying, hey, you're using the runtime only build and we don't know how to handle templates. And so if you're using the runtime only build, you'll have to manually write render functions, right? But then how does that even make sense? Because it works with Vue Loader, right? So the answer is that because Vue's compiler not only can run in the browser, it can only run in Node.js, and Vue Loader essentially bundles the compiler inside it as well. So if you've installed Vue Loader manually yourself, you probably have noticed that it has this peer dependency called Vue Template Compiler, and that's exactly the same compiler that the full Vue build uses in the browser to compile templates. So when you use Vue Loader with Webpack, all of the templates are already compiled into JavaScript when you ship your code to the browser. So this is what we call template pre-compilation. This compilation is done when you build your application at build time. So it actually has a performance benefit, because we no longer have to parse and compile and generate these functions at runtime when the user opens your page. When the user opens your page, it's already all JavaScript. There's no templates, there is no parsing, there is no code generation. It's already all JavaScript. So whenever you can, you should probably leverage template pre-compilation if you're building something performance sensitive. Luckily, the template compilation usually is fast enough. It only takes a few milliseconds for most of the time. So it's still acceptable in most cases if you value the convenience of just using the standalone build and being able to use Vue without any build tools. But as Jeffrey has demonstrated, Laravel now comes with pretty slick integration with Webpack. So it doesn't really require much effort on your part, so you should probably leverage that. Okay, so another thing that I want to mention is ing DOM versus string templates. This is another common source of confusion. So what does ing DOM versus string templates mean, right? They're all templates, but the essence of the question is, where does the template come from, right? So as we know, there are many ways to mount a Vue component, to mount a Vue instance. You can use the L option. You can directly give it the template option, and the template option can either be an ID selector or a direct template string, or you can mount the instance to an element. So The only thing that makes difference is whether you wrote your templates directly in the HTML. If your templates are inside HTML rather than in JavaScript, then it's considered in DOM. And the significance of the in DOM template is that it's parsed by the browser first before Vue can access it. Raw HTML is first parsed by the browser, then retrieved. There's a typo there. Then retrieved by Vue via outer HTML. So there is a little overhead here, but the more important thing to note is that during this step, during the parsed by the browser step, browsers will actually do something to your template, right? Because HTML is case insensitive. By spec, it's case insensitive. So browsers will try to normalize the HTML string when you ask for it. It normalizes away all the case information before we can even do anything. So what this means is these two examples. For example, when you use something like camel case prop or a camel case event inside your templates, and if you're using in DOM templates, they are just all turned into all lowercase when Vue actually has a chance to finally have the chance to parse it. This is why sometimes we recommend using kebab case, the dash delimitered case in your templates, while you can still use camel case in JavaScript. But maybe, but a trick that many of you probably don't know is if you're not using in DOM templates in Vue 2, for example, you're using Vue Loader. So Vue Loader is not considered in DOM templates because the file is directly parsed by Vue Loader inside Node.js, right? So you're using Vue Loader, or you are directly passing a template string to your Vue instance inside JavaScript. These are considered non-in-DOM templates, and you can actually use these camel case versions because the case information is preserved as long as because they're not normalized by the browser. So you can use this if you're using non-in-DOM templates. You can also, there's also another thing, these self-closing tags. I've seen many users try to self-close tags in their templates. And interestingly, in HTML5, this is actually not a valid syntax. In HTML5, a self-closing tag, there is actually no concept of self-closing tags. There are some tags that are called unary tags. For example, input. You don't need a closing tag for it. It's just assume it can never have children. Therefore, it terminates itself. However, when you say write a div like this, the HTML per HTML5, the browser will think you are just, this is the equivalent of a starting div tag, and it will not consider it closed. So if you have something that follows this div, this span will actually become a children of this div instead of a sibling of it. So you should avoid doing this if you are using in-DOM templates. And again, luckily, if you're using string templates, this would actually work because Vue's parser actually handles this case and knows you're trying to close this tag, and it would work as you expect. But still, it's kind of important to know the difference between all these browser behavior quirks so that you know you are not falling into some of the common gotchas. So that's all I have for today. I think I can take some questions.
Okay, thank you, Evan. 1 second, let me come back up here. Okay, so first off, great job of the talk. Internet stayed good, so that was great. The first one, it was not a question, but people just wanted to say thank you for the great job on the docs, and that you do a great job with that, and they find that super useful. So thank you.
Thanks.
We also have another one here. When will you be able to view init Wex my project?
Wait, what is the question?
I know this is going to be hard, these technical ones. So they want to like init with the Wex. Is that how you say it? W-E?
Wex?
Yeah.
Oh, weeks.
Weeks. There you go. Weeks.
Okay.
Like view init week project name.
So when will they be able to use Vue in weeks? Is that a question?
View init weeks.
Oh, Vue init weeks.
Yeah.
Okay. Yeah. So that's something in the works. We are so the weeks team is undergoing some internal like organization changes right now. So it's kind of a bit in flux. We're actually negotiating some new collaboration formats at this moment, but once that's settled, Vue init weeks. Actually, there is already a working template. We just haven't put it into the official like Vue Templates organization yet.
Mm-hmm.
So we're still waiting for some things to finalize and stabilize a little bit. And once we think it's ready, we'll just move it to there, and then boom, you can init weeks projects with Vue CLI. And it'll actually be in the long term, it'll actually be a kind of like it can work both ways. You can init a weeks project using Vue CLI. You can also init a weeks project directly with weeks its own CLI. I know it's kind of weird, but this is mostly because Vue CLI is very flexible. We don't actually it's mostly a scaffolding tool, but you can use whatever way you prefer to scaffold a new weeks project. And honestly, I don't have a very clear timeline for it, but I imagine it will be within a month.
Okay. Well,
I hope.
That's not bad. That's a reasonable timeline in open source, I think, within a month. Pardon me if you already answered this, but there's a question about if you're kind of planning like a Vue native.
So Vue native is that's essentially what Weeks is the role that Weeks is filling right now. And to be honest, something like Vue native is not something that an individual would be able to handle. The scope of a project like that is just too big because it involves you have to cross 3 stacks. Like you have to be an expert in web technologies and iOS and Android all at the same time, which is just I can't imagine doing that myself. So if you know about it, like Facebook has like more than 20 people working on React Native, and Alibaba has like probably more than 30 people working on Weeks. So it actually involves a lot of work to create a native bridge for these rendering engines. So
yeah, that makes sense. We have a couple more here. Maybe you could just talk a little bit about, and I've heard you talk about this at Laracon, but just for the online community, kind of the influence is a question, kind of influence of the Laravel community on Vue, and like Jeff's, Vue series, and just that kind of Laravel community and Vue kind of collaboration that's going on right now.
So Vue is, I think Laravel community has really given Vue a very good perspective on what developers in the wild are actually looking for. And it's, and I think there is this, also like before Laravel community picked up on Vue, I think the JavaScript community is sort of, so when we talk about JavaScript frameworks, inside the JavaScript community, we always just assume everyone is using JavaScript, everyone is an expert front-end developer, everyone uses Node.js. There are a lot of assumptions inside this echoing chamber that kind of pushes you into designs that just cater to a specific mindset. But Laravel community actually actually kind of reinforced my uh, my idea that the web developer community is very, very diverse, and uh, it's it's not like you have this one stereotypical kind of developer that just wants the same way of doing everything. And it's also important to have different frameworks cater to the different, uh, you can say, habits, or um, I guess fits your mental model better.
Right.
Right. So I think Vue is kind of carrying that mission of being the framework that just being welcome, and not not intimidating people who don't consider them like front end rock stars and stuff. And I think that's important because at the end of the day, you just have to have the tools that allow you to efficiently handle front end work, even if you don't spend 100% of your time on front end. And we really value that that value that Vue provides, and we want to keep doing a good job at that. And I think the Laravel community is kind of the driving force for us to keep doing that. Yeah.
Yeah, that's great. I mean, that's like, I think like exactly like you said, there's that full-time front-end developer world where it's like, yes, they are totally immersed in it and know the difference between every JavaScript framework and all those things.
Yeah.
Then you have probably the majority of developers, right, who are have to work across the whole stack and maybe don't have as much time to go down deep for 2 weeks on the React versus Vue versus Angular or whatever. And so having that accessibility of it is super important, and to be able to make something useful in a day with it, and just to get your feet wet and not have to spend a week just figuring out what the heck's going on to produce a kind of hello world sort of example. So, all right, well, that's great, man. So there are more questions for you in the Slack if you want to take a look at those. And thanks a lot for participating. I'm glad the internet held up. That's great. And thanks for coming to Laracon Online.
Cool. So I guess I'll just I can answer the question in Slack, right?
Yeah, so you can go ahead over Slack channel questions for Evan, so you can take a look in there, and people are flying in with them. And they're also answering the others, which is great. So you're not on the hook for every single question in there, but there are a bunch coming in now as well. So check those out.
Okay.
All right. Thanks a lot.
Oh, all right.
I'm going to make you a viewer. Bye. All right. We're back. So it's break time, and we're going to stick with our schedule. Sorry for looking down here, but I got the other computer going. Okay, so we're going to take a break till 11:15 Eastern time. Check the website. We have every time zone converters and all kinds of stuff, but basically 25 minutes here or so. So we'll be back at 11:15